April 2nd, 2018, and I'd like to specifically speak about the integration of relativity with quantum theory using the framework of the cosmology of light that I've been exploring over the last few weeks. So I'm going to start by summarizing the seed equation, and in the seed equation there's a process of quantization that happens, and this quantization is a fourfold quantization, and so there's a modification to quantum theory, and based on that modification, essentially that forms the basis for integrating relativity, special relativity, general relativity with quantum theory. And so that's what I want to explore. So I'm going to recap the seed equation, and I'm going to do so quickly. One can always refer to previous videos to look at it in more detail. So if light is traveling at an infinite speed, then what we have is a reality that has properties of presence, power, knowledge, and harmony. Now, when we have light traveling at c, which is 86,000 miles per second, then we have a reality of the physical, vital, mental, and connection. And there's a symmetry between the four properties here and here. But further, as we know, in this material layer of existence, there's infinite diversity. So just mathematically, the question is, how does this unity become the infinite diversity that we experience? And so we had proposed a couple of mathematical transformations related to the speed of light. And so we have light traveling at a speed greater than c but less than infinity, and let's depict that by k, so a reality set up by light traveling at the speed of k. Then we had proposed that essentially that creates a number of fields, and these fields expand out the possibilities existing in the fourfoldness of presence, power, knowledge, and harmony. So we have a set of presence, we have a set of power, set of knowledge, set of harmony that has many elements that create, in a sense, independent fields. Now we have further a reality set by light traveling at n being higher than c but less than k. And here, essentially, there is a combination of the different elements of the four sets that create unique seeds that manifest as waves. And we can depict this mathematically as a multiplication of the set of presence times the set of power times the set of knowledge times the set of harmony. And further, as one layer of a light relates to the other, there's a process of quantization that happens. To simplify, we're just going to consider the quantization between this layer n and c, since this is concerned with the layer of infinite seeds and how they relate to this material layer here. So we can think of this whole notion as the seed equation or the light matrix, and exploring further this notion of quantization as it relates to the seeds. So we can think of, if we think about this layer of seeds, then we can think of space as basically being a function of the number of seeds, but the seeds themselves depict different kinds of archetypes, and so we can think of that as a function of light's property of knowledge. Similarly, when we think about time, it's a function of the maturity of seeds, and we can think of that as a function of light's property of power. And when we think about gravity, we can think of that as a function of the collectivity of seeds, and that in itself is a function of light's property of harmony. And when we think of energy, that's a function of the materialization of seeds. And we can think of that as a function of light's property of presence. So, as in this first kind of quantization happens between this layer and this layer, it automatically creates these emergent realities of space, time, gravity, and energy. So the important point here is that if we were to consider what absolute reality is, then we may say that it's when light travels at an infinite speed, and then everything else is emergent. And in particular, as these vast set of seeds materializes at this material plane, in that process, the materialization itself creates space, time, gravity, and energy. Now, we had also explored earlier an equation for the seed, for the uniqueness of every seed. And so I'm going to relate these four emergent properties of space, time, gravity, and energy in terms of the equation for the seed that we had derived earlier. And just to summarize, the seed, I'll depict that by I, c to the base I, was equal to ax plus by, where this element can repeat itself from 0 to n times with a different b and a different y, but let me explain that. So we have where x and y are both elements of the set of presence, the set of power, the set of knowledge, and the set of harmony, but a and b are integers where a is basically greater than b. And so we would have a unique seed in which you would have a primary element and then a number of secondary elements, and that would uniquely define a vast number of seeds that would then become the basis for the materialization at this layer over here. Now, when we think about the fourfold quantization along the space-time, gravity, and energy dimensions, we may summarize this as the quantization along the space dimension as essentially being some Planck's constant, and here related to the way that knowledge manifests at this untransformed layer. So I'm referring to this layer where light's traveling at c as untransformed. I refer to this layer as metal layer 1, metal layer 2, and this layer where light travels at infinity at metal level 3. So we have basically some quantization constant times the seed k, since space is related to k in this scheme of things. Similarly, we have the quantization for time, where you have a Planck's constant related to power and multiplied by the seed for power. We have quantization of gravity, which is related to a Planck's constant of harmony times a seed of harmony. And then we have quantization at the energy level, where a Planck's constant related to presence and a seed for presence. So this defines a fourfold quantization, and now I want to use essentially these derived equations to look at a number of physical situations and explain them in terms of this fourfold scheme of quantization. So I'm going to consider a situation at the level of atomic particles, at the level of unit space, at the level of a complex planet like Earth, at the level where a particle approaches the speed of light c, and then also I'm going to consider situations where general relativity is known to play in, such as the black hole and a cosmic bounce. So let's first consider this atomic space, and I'm going to refer to, so the essential, what I'm trying to draw insight into is how this quantization is going to happen between this layer here of infinite seeds and this material layer here based on this fourfold scheme of quantization. So I'm going to refer to the quantization as big Q, and then for at the atomic particle level, so just atomic particle, and I'm going to relate it to this fourfold scheme of quantization just pictorially. So we have space, time, gravity, and energy, and all things being equal, what we're suggesting is that the quanta, if you will, is a result of the equally of these four different dimensions here. So I'll depict that just graphically as the quanta being at this atomic particle level being something like this. Now when we think of a larger space, and I'll call that unit space, US for unit space, we would expect that that would be some kind of at least a sigma of the quantization at the atomic particle level, and so we could depict that as space, time, gravity, and energy. And the rationale here is that if we have a single material seed over here that's manifesting, that manifestation has different components to it. There's the way that it shows up in space, then there's the way it matures in time, the way it may interact with other seeds, and the way that it materializes. So there is a basic fourfold quantization, and over here, if this quantization at the atomic particle level is here, then unit space that consists of perhaps many different material seeds, it could be just some kind of a transformation of this so that it's larger. So we would expect it to be a sigma of this, so it's simply related in this kind of manner. Now if we consider something a little more complex, so a planet such as Earth, so I'll just call that a big planet, a quanta big planet. So how does this scheme of large number of seeds materialize on a planet like Earth? Then we would expect it would be some kind of sigma of all the seeds that exist on planet Earth. So certainly a unit space, but however there's one kind of complication that sets in, since we're speaking about a number of irreversible processes that happen when these different seeds and the maturity of the seeds happen. So time is going to get elongated disproportionately. So if we consider this to be a unit space, the quanta of a unit space, and then if we look at, again, the space, time, gravity, energy, then what we may expect is that there's an elongation as things work themselves out in longer time. So this would be kind of how that cumulative or composite quanta looks like. So it would be, there'd be two components. There's the summation of the quantum at unit space, and this is modified by the quanta of time, which is depicted by this. So this is kind of like what this composite quanta would look like. Now let's step up a level of complexity and consider what would happen as, say, a set of particles approach the speed of light. So I'll just call that Q particle. So we're looking at the composite quanta as particles approach the speed of light, and considering the same scheme here, space, time, gravity, energy. Now a way to think about this is from the point of view of an observer who's seeing these particles, and in the observer space there's a huge number of these seeds, but in the observed space there's much fewer seeds, so space is compressed, the maturity of these seeds is compressed, so time kind of slows down or is compressed, gravity is compressed. But since you've got velocity that's now approaching the boundary between this layer and this layer, um, the composite quanta is going to change along this dimension, and the energy or mass is going to increase tremendously, and that can be depicted as a composite quanta of this nature here, which is essentially looking at special relativity from the point of view of how these different seeds interact and work themselves out. Now, if you consider a situation of general relativity, say of a black hole, so what's the composite quanta at the level of a black hole? And again, thinking about these four dimensions of quantization, then we know that in a black hole there's a compression of matter, and basically we can hypothesize that those seeds break down and perhaps create a smaller set of much more complex seeds. The way we would depict that is that there's a modification. So if we think about the composite particle, rather quanta for a black hole, then there's a modification along the space dimension, the quantization dimension, which is, if we use this equation here, we have HUK, but then there's a sigma of the seeds along the knowledge dimension. So there's a modification here. If we think about, so there's a compression, so if we think about, say, the unit space as being just invoking this one here, and then relatively, let's just say that there's a compression of the space, and then if we think about time, so now we have this modified seed which is going to play out, mature differently, and so there's a modification along the time dimension, and that's using this equation here, where you have Planck's constant related to power, and then a sigma related to power. So the time is going to basically expand out, and then you have a modification along the gravity dimension, which is known to be much greater, or hypothesized to be much greater, due to the vast number of seeds that now come into a smaller seed. So we can depict that by the modification that happens along that harmony dimension, and then similarly there's a modification along the quantization for energy, which we would hypothesize is also a new kind of energy. And so this is what this kind of composite quanta might be here, and so we're looking at this composite quanta that has some kind of graphical shape like this. Now let's consider the last situation of a cosmic bounce, where you have hundreds of billions of basically stars converging in, galaxies and stars converging in to one point. And in this situation, we may hypothesize that it would be related to this. So we have the cosmic bounce, and the question is, how does the rematerialization occur once those seeds all come together? And if we use this as a basis over here, the composite quanta at the black hole, and just depict that by this kind of scheme, then basically what I would hypothesize is that you would have a composite quanta that had a lower space dimension but then much higher on the energy, time, and gravity dimensions, which would set up a new kind of physical dynamics for a re-expanding universe. and we would take basically these four equations. I'll just say QBH, but then we would expect to be much larger, and I'll just use exponential by a huge factor m to specify this quantum cosmic bounce, which is related to the composite quanta of a black hole times some massive multiplication. So essentially, just stepping back, what we're saying is that there's now a way to, using this scheme here, the framework of cosmology of light, where there's a fourfold quantization, to look at different kinds of physical situations that occur or that have been hypothesized, and kind of explain them or understand what might happen physically based on this theory. And so in a sense, the basic mathematics that's depicted here, I would say, can be built on to create further this integration of a modified quantum theory and relativity.